Hello, everyone, and thank you very much for joining us today. I hope you're all safe from wherever you may be joining us from. My name is Jonah DeLongchamp, and I'll be your host for Live Quality Training Occam Level 2 presentation, which we're very excited to talk to you about today, and where we're going to actually give you an example of how a section of Occam Level 2 course would be held. Before we get into our seminar today, I want to mention to everyone to please ask us questions throughout the GoToWebinar tool, which is a question mark icon and a bubble which is on the toolbar on your right-hand side. It should be underneath the hand icon to raise your hand, which you can also feel free to use, and we'll address your questions at the end of our presentation. Now, I'd like to give you a brief introduction to who we are here at Wenzel. Wenzel is the largest family-owned metrology founding company, founded in 1968 by Werner Wenzel, and now led by his daughter Heike Wenzel. We have approximately 650 employees worldwide, about half of which are in Germany, but with 17 subsidiaries worldwide and more than 50 sales and service partners as well. Our family looks after more than 10,000 Wenzel machines as well as third-party machines. This includes not just CMMs, but high optical speed scanning and computer tomography inspection equipment. So here in this slide is probably the best shot of where our products are made. And as you can see, the different colored and shaped ceilings, which is a nice signature of how far we came as a company. As a family company, we pride ourselves on giving personal touch to every customer. We make your challenges our challenges so that your success is our success. And recently, we've just celebrated our 50th anniversary, and we are looking forward to the next 50 years. As I said before, my name is Jonah DeLongchamp, and I joined the Wenzel America team as an application engineer back in August of 2009 until January of this year, where I took over my new role as product specialist for portable metrology for the NAFTA region. And today I'm joined by my colleague Mariano Marks, and I'll turn it over to Mariano now.
Hello, everyone. Thank you very much, Jonah. Always a pleasure. As Jonah said, my name is Mariano Marks, and I am the application manager here at Wenzel America. I oversee trainings, demos, SMAs, I wear many different hats, and I have been a part of the Wenzel team here since September of 2016. So I actually just hit my 4-year anniversary. So thank you, everyone, for your nice LinkedIn comments, and I'm looking forward to many more. So today, I'd like to talk to you about what Aukom is all about, particularly to deliver a small training and a section of the Level 2 course. But before I do that, I wanted to let you know about how Aukom helps your quality department. So Aukom is a suite of courses designed for metrologists, production engineers, design engineers, and even managers, and really anybody in the field of metrology to enhance their skill set through these 1-week training courses. This is going to help you do 3 things. It's going to help you reduce costs, it's going to help you minimize waste, and it's going to help you make effective decisions for your production.
So Mariano, this Aukom, is it an acronym for anything? And if so, what does it mean?
Yeah, so Aukom stands for Ausbildung Koordinatenmesstechnik. So I'm probably botching the pronunciation, but in German, it translates to coordinate measurement training. And so this program was started 2 decades ago by a group of metrology companies in collaboration with universities and industry experts with the aim of providing the same foundational knowledge to those who take the courses. This is almost a pet peeve of mine, for example, when providing support on our hotline, where I see terminology that, even though I know what is trying to be said, is misused. Maybe it's just not the regular operator working that day, perhaps. But nevertheless, having the same concepts and even language be used throughout the manufacturing process is invaluable. I don't have to say so for those of you who are operating internationally. So this is why these courses are exactly the same, no matter what continent they're taken in. I'd like to be the first one to deliver a training in Antarctica if I have the chance, though I don't think we've established the Aukom flag there yet. So, and I'm actually from Argentina, so it wouldn't be a far trip from there at all. But anyway, so when I first started here at Wenzel, my first metrology affair was with gears. Spurs, bevel gears, racks, worms, you name it. And a well-known concern in the gear industry is the gap of expertise and information that is anticipated due to a generation that will be leaving it and the lack of people that are entering it, either from no interest or absence of the tools to facilitate this transfer of knowledge. If I want to search something on the internet, I go to Google. If I wanted coffee, I'd probably go to Starbucks. If I wanted the best all granite CMM frame, well, who else but Wenzel? If I wanted to learn something, I can't say I didn't love all the math and physics courses I took in college, go Eagles. But if I was looking for metrology knowledge, you can now get it directly from the experts.
And Mariano, can you tell us a little bit about the structure of these Occam courses?
Yeah, definitely. So what you're seeing here on the screen are the Aukom Level 1 through Aukom Level 3 courses, which have 4 days of materials in them, as well as the Aukom GD&T course, which is 3 days of material. And the great thing is that for the Aukom Level 1s through 3 days, courses, there is a 5th day of which in the morning we take a test. So this test means that the course is certifiable and you're getting the latest knowledge in the field of metrology because the content is continuously kept up to date. I've also heard of companies which have, for example, operators who, if all they do is place the part on the CMM and run a program, then they might need to be certified to Aukom Level 1 in order to be able to do so. And if they maybe need to write a program for the CMM, then they have to be certified to at least Aukom Level 2. So this makes the results that are provided by the quality department more reliable and credible. So this is a slide that we show in every Aukom because it's that important. And this slide demonstrates exactly what I just mentioned, which is that the results that we obtain from our inspection equipment must reflect what our part is actually like. Because if the part is okay and the measurement is okay, then everything is great. Everything's all right with the world, we can move on. But if the part is not okay, and we say that the measurement is okay, this can be dangerous. And we can see failures in the fields. You see all the recalls maybe that you've seen in the news for different industries, and people can actually get hurt. Conversely, if you say that the measurement is not okay, but the part is actually okay, this can be costly because then in your process, you're chasing your tail and you end up wasting time, money, and energy. What we do want is, if the part is not okay, to also reflect that the measurement is not okay. And so here are the topics that you'd find in the level 2 course specifically. So we're diving a little bit more into the different sensor types. They each get their own unit here. Even CT is now discussed in level 2. So if you didn't get a chance to listen to Chrissy and mine's seminar about CT, come take our Occam level 2 course. Freeform surfaces, they need their own unit because they're unique in and of themselves. And we throw some more math at you when talking about evaluations and measurement uncertainty. Don't worry though, nothing which you'd need a calculator for. But again, all of this is so that if you come across this, you know exactly what to do.
And Mariana, you mentioned that there's an exam at the end of the course. Do you do anything to help your students prepare for this exam?
Yeah, totally, Jonah. So we have end of unit questions for all the units except the first and last ones because they're shorter, they're introductory and a conclusion units. We also have a practice exam that I give to students the day before the test, a copy if they'd like to take it again and study overnight. And we review before the exam itself as well so that we can make you successful come test day. All right, now we'll get into some awesome Occam. So the topics I'd like to train you on today is from a section of Unit 3, which has to do with form orientation and location tolerances. But I'm just going to give you a snippet of the form tolerances, in particular straightness. These are the controls that you'd want to use when the shape, if you would, of your part needs to be constrained. So the picture you see of this cylinder, which to the eye looks perfect, is really not so perfect in its shape when you look a little closer. Next to it is a graphic, which is exaggerated and is really what we want our metrology software to show us. The true form, which in this case is trilobish, if you would. So this is very clear when we have enough data, which we touched on a little bit yesterday in our Aukom Level 1 presentation.
Yeah, so Mariano, before we go any further, what could cause this type of distortion, what we see on the right-hand side of the screen here?
I'm glad you asked, because this is also something we touch on in Aukom. This particular deformation could have been from vibration during machining or over tightening of a 3-jog chuck during production. So it's easy to comprehend how these errors can come about, but it's also easy to overlook and also literally look over when it's not presented in such a way. You might have production personnel who don't want to look at this data because they're not sure what they're looking at. So what we're able to provide in the quality department with software like ours is a magnified color graphic, maybe, right, showing the deviations from the nominal element, for example. Then on the left, we have the 6 form controls. And when I say form controls, the concept that clicked for me personally is thinking of the shape of my element kind of by itself. So I'm just picturing it, my cylinder or line, kind of floating in space by itself. And to quote Metallica, nothing else matters. So this is what they're getting at with the statement on the bottom right. So now I'm seeing if my plane is planar enough and if my cylinder is cylindrical enough. And these first 4 elements are my standard geometries, is what they're called. They're defined more simply, mathematically speaking.
And if you're not working with one of these types of shapes, a cylinder or plane or a line as an example.
Yeah, so these should be the bottom 2, right, Jonah?
Yeah.
If you have something that isn't one of these 4 shapes, then it's a non-standard geometry, which we can call either a curve or sometimes spline, or it's a free-form surface. Regarding form, since these last 2 can encompass many elements, I then think of these as how blobby is my blob, right? This shape is how the blob came out in the measurement close to the nominal blob. And as silly as it may sound, this is what congeals the concept in my mind, so that it is similar to how I was thinking about it for the plane and cylinder I just mentioned. So I presented to the class because it might help them out as well.
That's definitely a different way of thinking about it, for sure.
Right? And since we're talking about simply the shape of an element, we won't see the callouts in the print for the form controls for the standard geometries have any datums. So then I tell myself, how straight is my line? How round is my circle? And it's not to anything. So if I have to say to, then I know that a datum is required. Take perpendicularity for a moment. You'd say, how perpendicular is this axis or something to a plane? So then I need a datum. So this is when that concept clicked for me and made it easier to understand other concepts. As a last comment, you'll notice that the last sentence of the statement at the bottom right says that the form is calculated using the minimum zone method.
Yeah, or the Chebyshev, which we discussed yesterday during the Aukom Level 1 training.
Yeah, so it just goes to show you how all of this builds on itself. So let's look at how straightness can be applied and how it works, which I really enjoy how it is presented, just like in the ASME Y14.5 standard. In the this on the drawing means this in real life style. And I realized I just called the standard enjoyable, but someone's got to do it. I think I'll be the nerd. Although if I'm going to call myself a nerd, I might as well go the whole way and say that I have gotten certified to the 1994 ASME Y14.5 standards to the technologist level. So I'm going to defend my title. But although the ASME standard is mainly what we use here in the US, there is also the ISO standard that is used internationally. So Aukom has made the effort to distinguish the differences if there are any throughout the course. And so here to go into the straightness call out that we see on this simple part, it's kind of thick ruler, we have the straightness call out pointing to a plane here. And so we want to figure out what it's trying to tell us. So this call out, this feature control frame, has only one interpretation. Since ASME, that's what it is. It's just a drawing standard. And so we want to communicate exactly what it's telling us, which is mentioned in the middle here. The top call out can be thought about, as it says in the middle, the extracted line, which are the black dots, which is the data that was gathered from our inspection equipment. It says must not exceed at any point the tolerance zone. So this tolerance zone has a particular shape. In this case, it's two parallel straight lines, and they're spaced 0.1 millimeters apart in this case, which is what it states in the feature control frame, 0.1. So the software is going to spit out a value, right? And the value that it's going to give to us is described here at the bottom. The deviation of our straightness would be the smallest distance between two associated parallel lines. So we want to squeeze that data as much as possible, essentially. And this describes this shape, the form of our line in this case. So as closest as those two parallel lines can get together, that distance in red there, d equals min, that is our calculation.
With the Chebyshev. Yep.
Exit coming again, we're using the Chebyshev association method. And these both situations are the same for ISO and ASME. Then we have a couple of more examples, because straightness, when you see a call out, shouldn't assume it's all the same. So at the top here, they're showing us a call out that is pointing now not to a plane, but to a cylinder. And what you see below the diagram, it says each surface line is toleranced. So in this particular example, we would need to gather lines with our, let's say, scanning probe all along the surface of that cylinder. So we're just getting a bunch of lines. So once we get all those lines, we would do analysis on each one of those. So it's not when you see a call out for one straightness, you're just doing one thing.
So to do this properly, you'd need to check the part all the way around in this case.
Yeah, and of course you wouldn't be there all day. You would need to, this is where you might go back to production and say, you have to strike a balance. How much am I going to inspect of the part? Is it going to be every 30 degrees? Or maybe you're going to check it in a place where you expect some error or something like that, right? And then the description or the interpretation is on the right-hand side in the blue box. And then for the bottom case, what we have here is another differing case where you see the straightness call out looks like similar, but it's actually pointing. You can see the arrows are kind of touching together between the leader line of the feature control frame and the arrows that point to the diameter or size of the part. When the arrows are touching like that, that means that we're tolerancing the axis of this element. And that's what you see on the picture of the right. And I really like how they show this blobby, exaggerated picture, because I think this drives the concept easier as well. We see that the axis now is what has to be straight, not anything on the surface. This is really what it's saying. And so in a similar fashion, we would get these data points of the axis, maybe by scanning multiple circles on the cylinder and looking at the collection of those center points. So you really get a feel for how much data you would have to gather for all of these different callouts. It's maybe more than you thought. And for both of these scenarios, they're both the same between ISO and ASME. So then we have a scenario where we're kind of going back to the first one, straightness on a plane, but it's showing in two different orientations. So we have one way, straightness of a plane, any cross section on the plane to 0.05, whatever units it is, and then 0.03 the other way. So go ahead, Jonas.
So the actual analysis is the same, but the symbology is a little bit different then.
Yes, as you can see on the bottom right, we're going to analyze it the same way, but the way that it's shown on an isoprint versus an ASME might be different, the way they go about it. So it's also nice to know these details if you're getting a print from another country or something like that, right? So the other thing that you would notice about the Aukom courses is that it's manufacturer neutral, is the term that I like to use. So much so that in level 1, we've taken out any branding from all pictures and made them look more generic with grayscale colors, because again, the focus is on the training material. We want to get that same foundational knowledge to everyone. And furthermore, you'd be glad to know that students are getting the same exact content, not only anywhere you get trained in the world, but no matter who trains you, since that's what Occam seems to accomplish throughout the industry. So if you have the same part that's being measured in Madagascar and India, then you're going to get the same correct results at the end of your measurement reports. So this example over here is showing the straightness and giving an example of how you're thinking about it with the function of your part. So you can see towards the bottom, we're going to have to insert the pin into the bore. So again, we're going to control the form of the axis of this bore. As it says the condition, the bore axis must not be bent. So maybe we would scan it or take points as it's showing on the top right. Those yellow paths of the metrology software is going to collect the data when the probe goes about getting the points from the bore. And in the end, in a nutshell, if you want to think about it this way, you don't want to have the pin be in the shape of a banana, right? If you want to think about it that way. But it's important to note that the straightness callout is only saying the shape of the pin shouldn't be a banana or the bore. So essentially, how is the axis kind of shaping? Is it wiggly? Is it a banana? Doesn't say about the size, which kind of correlates with the form, right? But in essence, in metrology, we're controlling two different things. So maybe you can be shaped like a banana as long as the size is smaller. So,
and I've trained a lot of classes over the years here at Wenzel for different softwares and different levels of classes. And just for the basic class, boy, if the students had this knowledge prior to them coming to class, it would really help them and the instructor as well, because they already have all this foundation built up for them.
and glad you said that. So I like to refer to this suite of courses as a step ladder that merges perfectly with our software offerings or other training provided. So you maybe take the Occam level 1 course first to get your feet wet, then maybe you take the Quartus basic training with URI, and then after that you get more training with level 2, and then maybe you go to an advanced class, or you go to the GD&T course. You can kind of branch out from there. So and during class, one of my favorite things is when the students interact with each other. So whether I'm teaching on site at one company or in the office with a mixed class, this right here might be a point in the class where a student realizes their production process a little bit more maybe, and matches it up with the type of sensor they have. So if it's a scanning sensor, they'll ask another student that has a scanning sensor how they go about their inspection, maybe the speed of their CMM, the type of stylus they use, how many points they're gathering, because they're all from different backgrounds. They have different machines, different sensors, and they measure different parts with different materials. So they end up learning from each other. And this is really the greatest thing about Aukom, that we can come together to have the same understanding about our own process, which in the end makes all of us successful, I think.
Absolutely, that makes perfect sense to me. And thank you, Mariano, for that look into Occam level 2.
Thank you, John. Always a pleasure working with you.
And thank you everyone else for attending our live Occam training, Occam level 2 presentation.
I also want to make sure to have you guys check out a podcast that I did with the folks at Philips Precision. It was my first podcast. It was an awesome experience, and I had the chance to talk about how courses like Aukom kind of correlate with other educational institutions around our country.
And please, everyone, make sure to submit any questions if you still have them. And in the meantime, let's now take a look at some of the questions submitted by the audience. So we have a question here, due to 2020 and the pandemic, the COVID, are you able to teach this Occam level 2 remotely?
So actually, what we're able to, since we're very flexible and adapt to times, what we've been able to do, or we can do, is teach the Aukom level 1s and Aukom GD&T courses over GoToMeeting. So we've had great success with other trainings with GoToMeeting. You've been into them too. And so that's something we can do at the moment.
And you only have to be Aukom level 1 to take your GD&T.
So that's a great point. So if you want to take Aukom level 2, you have to have passed the Aukom level 1 exam.
Okay.
If you want to take Aukom level 3, you have to have passed Aukom level 2 and also have participated in the Aukom GD&T seminar, which doesn't have a test at the moment. So it's just a participation certificate for now.
Okay, I think that answers that. Another question here from the audience for the line and surface profile. Do they have to be a line or surface, or can they be anything?
Yeah, so the curve and the freeform surface, they can be any shape, and then essentially when you apply the form tolerance, you are able to do, it may or may not have a datum. So you can do profile or line profile to itself, or it might be controlled by further datums. You can do up to the 6 degrees of freedom. So definitely,
Okay.
Yeah.
Great. And there's no other questions from the audience currently, but I have a question for you. Mariano, what's your favorite memory from training Aukom, I guess?
Yeah, so recently, definitely, we had a group of students that was able to go through the whole curriculum, which is awesome because not only, and I think I had talked to them before and knew how to because of the Quartus software they have, but they got into Aukom and every class was different because they were different students, right? But they went all the way from level 1 to GD&T, so they were able to learn a lot. And then I was really glad to see that their department invested in them. And then when we talked to them afterwards, they're able to use the same terminology, met exactly the goal that Aukom is trying to do. So I was really happy about that.
Great, thank you. Well, with that being said, that wraps up our presentation for today. And thank you, everyone.
Thank you. Have a great day.